So in this video we are going to show through the use of the coordinate plane that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse, where, just for clarification, the geometric mean of two things is, if you have one thing and the other, you multiply them and you take the square root. Okay? That is the geometric mean. Okay? So we're going to do this using the coordinate plane, and I have just simply drawn a coordinate space here. We're going to start with a circle of 5 units long. Now, this is not a rigorous proof. This is it proves it in this one case, but we're going to hold it generally true because without doing formal geometric methods, you can't prove it for all cases without doing all cases. So we have a circle of radius 5 that I am now drawing, okay, about the origin. Okay. I'm just going to sweep that around. The good thing is that I can keep the same size circle very easily, even if there's a slip somewhere. Okay. So we sweep it around just to say that we have now a circle in our coordinate plane. Okay? So we are going to make use of the theorem that states that any chord, any two pairs of chords that make an inscribed angle, so long as the remaining segment is the diameter, will make a right triangle in a circle. So we just require that this be one of the sides, right over here, which is 10 units long, 5 on each side of the center. Okay. And then we also require just a point. Any point that we choose on here will be valid. Okay. So we are actually going to choose a convenient point, one where the grid intersects at the point for 3. Okay. The radius of the circle is 5. Okay, and you can do that from the Pythagorean theorem or just straight up count how far it is away from the origin. Okay, we now need to construct the two chords that come from that point to the endpoints of the circle. Okay, so we're just going to draw those lines right here. And by definition, the inscribed angle is half of the central angle. The central angle is a linear one, so that means that the inscribed angle, by definition, is a right angle. Okay. If we construct the altitude is just perpendicular to the base of this triangle. It's convenient because this lies along the x-axis. Well, if we just go straight up, we're already perpendicular to the x-axis along the y-axis. Okay. So this right here is the altitude. Okay. Now, what's the length of the altitude? Well, the altitude, of course, is just the y component of this point. It's 3 units long. So, again, we're seeking to demonstrate that 3 is equal to the geometric mean of the hypotenuse segments. Okay? So how long are each of these segments? Well, if the radius is 5, the total diameter must be 10. Okay? If this is 4 units over, from here to here, then this is 1 unit. Okay? So one of those segments is 1. The other one is 5 plus 4 is 9 units long. Okay? So it's the geometric mean of 9 and 1, which is the square root of 9 times 1, which means that we just have the square root of 9, which is 3. So we have just shown for this one particular case that the length of the altitude for a right triangle, at least, is equal to the geometric mean of the two segments of the hypotenuse that it creates into segments.